Now we're going to start looking at step 7. That's the last stage of developing this client and server example. So step 7 says add any remaining optional features such as hostname, pause, logging and finish testing. So we could go up to this section where it says optional client interface features, where they're described. So you can have a /h option to change the host name. You can just have a /p option to change the port number, and potentially you could have any arbitrary number of parameters to the /e command. So we could look at implementing those first. So we could go to our Visual Studio, and we need to now switch to our project for our client called Connect. And again we could go to Visual SVN and let Visual SVN know that we're going to do a new update revision to protect ourselves from making any errors. So we're going to look at alterations to the arguments here. So we've got various arguments, and we can't assume that arg0 now necessarily has the /n or whatever in it, and that and it's not necessarily going to be connected to localhost. So we've probably got to start doing some different options here. So before we do the networking part, we probably have to process the arguments. So one of the things we could do is declare some string, for example the host. And we could set that to localhost. And we could declare an integer. For the port number, and that allows us to change those. So now we could use the port there, and then we could put the host there. So that allows us to put some code in to manipulate those values. Right, so as we can have a variable number of arguments in we probably need to set up a loop to go through all of them. So that could be a for loop starting for argument 0, going through all the args up to the length of the arguments, incrementing each time. So that's a little loop that will take us through all the arguments. And then inside there, we probably want to put a switch on args_vi, the particular one that we're looking at. So then, for example, if we've got this /h as one of the things we're looking at, we can now say the host equals args, and it's whatever is the argument following, and then we could put a break. Okay, so that's our switch. I haven't put the word case. So there's a case there. So that's updated the host if a /h is used. And then we could put a case if we have a /p. We could select port number is equal to something. Now we need an integer, but we've got a string, so we've got to do a convert to int 32 of args plus I. Allows us to change the port number. Based on things there. So now we can say what we want to do if we have something like a /e. Well, we've got this command string, so we could set the command string equal to echo, for example. Now what we need to do is if we move this up and put this up here, that allows us to change the command to echo if we've got a /e, and we could put some other function, other code in there as well, but we can handle /n in a similar way. Just got to process all of the valid arguments. And we have a /s. That's the valid command for the source. And then we've got a case for a /k. And we can put the command is valid for the sync. So those are all the valid commands that we could put. Oh, just a small typo there. So then we've got the default, meaning if it's not one of those, what do we do? Now that's possibly an error, but it's only an error if we're not already set the command to echo. So if the command is echo, it's not an error. So we could say if command is not equal to echo, then we will have this unrecognised. Command error. Then we've got else. Break it. So if it is an echo, we need to collect those arguments into something. So we could have something like a string the echo string, which we could set perhaps nothing to begin with, and then each time we've had a /e and we get something that's different, we could just add it on. So we could say echo string and we append whatever came after the /e, and if we haven't got a /e, it's unexpected. So that allows us to go around all the arguments, picking up a new host, a new port, and getting the correct echo string. So now we need to make some changes here. We now don't need to look, or we can check the args length here. So if we now need to say, well, the only thing that can have more than one argument is the echo. So we can actually say here, we don't need to check the arguments length actually, we can just because that's already been checked here. So the echo will have that, so we can now switch on our command. And now we can just say if the command is no op, we can output no op. In fact, we can even output the command. And if the command is source, we can output the command. If the command is sync, we can output the command. And now we can just put in the part for echo as well. And if the command is echo, we can write out followed by a space, followed by whatever is in the echo string, which we've already collected earlier, which could be one argument or several. Okay. So we've got that in. Let's see what we've got here. That's good. And then we deal with the response. So we've actually made the code much simpler just by putting this argument loop in there, followed by this try that handles all the pieces. Let's save that, and we can build the solution. So then we can go on and test that. So we need a server running, but we can go to one of our command prompts here. We need to start a server. Start G:, wait 241, respond, binary, debug, respond. So that starts the server, and then we can try our new client. Try the /ends, try the /e. Okay, so we've got an index out of range exception on the /e. And now we can actually quick go into the debug here and okay, so that says we've got a fault here. Because it's not the ++ that we want, it's I. So we can stop this running. So it's just that argument, so we can save that. We can build it again. That just shows you how easy it is to make a simple mistake. Right, we get hello. So hello world. Aha! You see we put the hello and world together without a space between them. So now what we need to do is actually say in here we need to stop this running. Okay. So whatever string was in there, we now need to put a space followed by that string, but we only want to do that if echo string had something in it. So we don't want to begin it with a space, so we actually want to say if echo string is equal to is not equal to nothing, you want to put a space on it. So if we've already got something in there, add a space before we add the argument, otherwise just put the argument in there. So let's build that again, and now we'll quickly check. We get hello world, which is the same as if we said hello world as one argument. We can now check what happens if we put /n hello world. We get unrecognized command, so it's checked the command out ahead of time, so it only allows those things. So if we put connect /x, we get unrecognized command. If we put connect /n/e, actually allows that as valid. If we put /n/n/n, allows that as valid. So that allows a command after a command after a command here. So there's a brief error there that we should only allow that if the command has not already been set. It's one of the ways we could do that, or we could allow that as valid. So we need to put a little check in there. So if command is currently unknown, we can set the command echo else so unfortunately else it's an error and it needs a bit more code, and that's this error case here. So if we get a /e and we already had an earlier command, it's faulty. And that's true for all of these commands, so we can only set the command when the command is currently unknown. It's a bit tedious, we've just got to paste the same structure in each of them, so if it's unknown we can set the command, and we've got to do the same for all of them. So let's think. So it's probably going to be quicker to copy the whole of that structure, paste that in there and there, and just change the command now to source and sync. So we've got some more thorough command checking now, which we can save, build the solution. And now if we try to put /n/n/n/n, we get /n/e, we get unrecognised command each time. So it only lets it through when we've got some valid commands. So that's most of the optional features for the client done. Let's briefly check. /h/n. We haven't tested /h and /n, so we could briefly test those. Connect /h localhost /n, that seems to work. Connect /n/h. Most it works either way round, and we can put /p43, and it seems to accept that as well. Right, now we need to work on some of the optional features for the server, and we'll just go and look at that. Now we need to look at the server and add the optional features to the server. So we just open our server project, and then we can tell Visual SVN that we wish to make some updates to it for a new revision. Okay, then we can quickly check our specification and see what the server optional server features. So the optional server features are that if we want to do it best, we could put some logging in a common log format, and if we do, we either do it to the console or we're told the file name. So those are the main features that we need. So if we want to do some logging, there are some standard ways of doing that, and here's one that I like. So it's quite common to take standard paradigms of doing things from the net, and here are some standard examples of writing some code. So we could take this example that we got from the internet of performing logging, and we could add it to our code. What we should do when we do this is acknowledge it, in our documentation that that's where this thing came from, but we need to amend it for our use. So one of the things is we need to go for a particular file name. So we could, for example, add a string for the file name there, and we could then make this log to a particular file. So when we create a new instance of a logging class we get given a file name, and then we can use that file name there. And in our code we would probably want to write out the message to the console, and then if the log file with name, this log file name was still null, we could exit there and not write it to the stream. So we've made some changes. The reason why we want this with a lock is we've got multiple threads, and with concurrency we have to make sure only one is writing to the log file at one time, which is why we have this class with a lock, and it manages the file name. So that's done some basic things there. So we can look back at our specification. We can see our message looks like it goes in here, and we've got a status, we've got a date of time, and we've got a host name. So we want to log a bit more information here. So in addition to that, we would want a host name, the message, and perhaps a status that we wanted to send out to the file, and we might want to combine those in a line with the date. So we can combine this with the date so we can make a line out of the host name, and we want to put in the two dashes that we saw, and then we want to put in the date and the time of now, and we want to change that to a string, and we want that string in a particular format. Now the toString for the date and time has a particular format, and you can say what format you want it to be. So if we go back to the spec again, we can say we want it to be like this format. That's the two hyphens. So we can say we want a square bracket, and then we want the day, and then we want the slash, and then we want month, and then we want a slash, and then we want year, and then we want a colon, and then there's the hours, and then a colon, and then the minutes, and then a colon, and then the seconds. And then it's got the time zone, which we can do with ZZ 00, and then we can put the closing square brackets. So that's that time by the format, and then we want to add our message, which is in some quotes. So It's going to be a space, a quote, and then the message, and then we want the same thing again. Quote, and then a space, and then we want the status. So then we formatted the line that we want to write, and so we now need to write out the line that we formed. Here. So that should enable us to write out the line. Now it did also say in the specification, which we can go back to here, ensure that if the log file is not writable, that the server does not fail. We may not have permission for the file. So we need a little bit of extra check here. So again, we can put a try. And a catch around writing the file just in case it fails, and then we can say something like console dot write line enable to write log file, and perhaps we want the name of the file. So that's handled that part. So based on a little template here, we've created a little class that does some logging for us, which we now have to invoke. So we can invoke that from this finally part here, so we want to call write to log here, and we want to put some information about the host, line, and our status here, but we haven't got a log object yet so that we can access the method. So we need to declare a logging object. And the easiest way is to just pass it as a parameter. So the do request is given information about where is to do the log, and then we could just do log write to log. So we've got to gather the information we now need to write to the log at this point. So we need some information about the status, we need some information about the host. So the information about the host is we can get from the connection. So we can do right at the top here. So the host so if you remember from the slides about sockets, a connection was made to a socket which is at an IP endpoint. So we can get the connection remote end point. So we should be able to get the IP endpoint of the connection, the remote endpoint, and we can get the address from there, and we can go to string. And that converts information from the connection and finds out the host that we need. So that's that information. Now this line that we've received comes from here, so we just need to get the information about the line and put it here. So string line here. So we declare the line there, we set it to nothing, and then we put the first line that we read into it, and that means that that line is now available. So we just need a status, and normally we can set the status to OK, and then for all of these the status will be OK, except for the one or two where it's not. So here we've got one where the status is not OK, so we could put status equals put unknown for unknown command, and here if we had an exception we could put status equals but we've had an exception. And now when we get to the finally, it knows the host, it knows the line, it knows the status, and it can call login, put out the date and time with this information. Okay. So we've added that to do request, but we now need to add that information into the call of do request so that we create the log. So that log has now got to come from this main program here. So we've passed in the information about the name of the log in here. So we probably need to put right in the top of the class here something like a public static login log, and then we can create a new log once we know the name, and then we could pass that instance of the log to the do request when we make a thread for it. So this thread then knows to send it to this log. So what we've got to do here is get the information about the file name. So let's do that. So let's start off with a file name as null, and then we've got to go for all the arguments like we had before. So we'll start at 0, and we'll go for args.length and then ++ I. So that goes through all the arguments, and then as we get each argument, we want to switch on the argument we're looking at. And then in the switch we want a case looking for the one that's /L, and when we have the one that's SL, we want to take the file name as the args and the one after the /L. And then we want to break because that's done. And then we have no other cases, so we want to default for everything else. And if we've got a default, we probably want to say console write line unknown option, and we can say which option was unknown is the one in args I. And then we can break. So this goes through all the arguments, it looks for the /L, if it's got anything else it gives an error message. So now before we call the run server, we can now say that make a log, which is a new version of logging with the file name that we were given. And if we didn't get any arguments, it created it with nut, and null went to the console. So let's see how that works. We've made very little changes. We've just looked for the argument /L there. We've added a logging class. We made an instance of it. We passed the logging class to our thing, and then we've written to the log. So let's start our server, and then we'll go to one of our command prompts. We'll try and connect to it with the /n, and you'll see it has got the IP address where we came from, it's got the date and the time in the correct format, it's got no op, and then it is looking like the thing, but we've got all this other extra information. So now we've got proper logging, we can actually delete all of these console write lines because we don't need them anymore. So we build it, we can run it again. And now, whatever we do, we're getting logged different things there. And we could run the server now with a /L, and it would also transcribe this to the file. So we can stop the server running now. So we've now done that optional part, and I've shown how you can pick some templates from the net, but you should always cite your sources where they came from if you get little templates from the net. And that's done that. Now there are some comments, so probably we should professionalize this a little more. We should add a few more things. So this is a thread safe method of writing to a log file. We can say initially the log console. So putting a few comments in on the suitable places. Here, say what we're doing. Common log format. File exit after switching to console. Here we want to say something like log file write to create concurrent filled writes. So as a catch file. So I've added a few comments to the code to explain what's going on. And that's that done. So we've done the optional features of the client, the optional features of the server, and now what is left is testing. So now to run the testing, we need the command prompt, and we can click on the scripts and just make sure we've run the setup script. So now we're ready to do T step 7 test. And we usually need to tell it the client and the server location. So 08241 respond in debug respond.exe, so that should get us both the client and the server, and it can run the various tests for the 7th step. So we're getting some OKs, we're getting some successful tests where it's trying out the optional parameters of /h and /p in different combinations. Now it's got a failure. Now it's checking that the server doesn't make any fails other than the one for /l. So here we got some output from our web server here, and you notice that it's got the expected output and the actual output. So we've used the P to connect to a port 80 for a web server. Here the expected output has line breaks in it, and the actual output doesn't have any line breaks in it, and that indicates a fault in where we output the text. So where the server would output the text, I've got the wrong one here, we need to go to the project for the client, because there's a fault on the client, and it's the part of the client here where it's handling the rest of the response. And you notice, although we've done a read line, we've done a write and not a write line, and here we've done a write and not a write line. So the test script has picked that one up, so we can do a save and we can build the solution again, and then it should be a very simple matter of using the up arrow to run the script again. It's running through the same tests again, and these ones that passed before are obviously still passing, and it's the ones a bit further down. So here we are, test 9 on a web server, it now says OK. Test 10, it's connecting to a different server on port 43, that's working, and now it's running the server to check it makes a log with a /l. And then it says, would you like some more tests? We can go, yes, and then it tries a few more tests. Oh, and we've crashed it. Okay, so what we've done here is it's crashed when we have a /h and we don't have any arguments. Okay, that's easy to fix. So you can see that the debug script is quite good for checking. So we probably should put a try. And a catch. Around here, and so then we can put a console right line and word error. We can put parameter error, something like that. And then we can put a return, so that the program exits. So we can save that, build it again, and then we can go back to our test script. Now running again the test of the /l option for the server. And then it wants the optional test, which is it's trying to do a /h with no arguments, a /p with no arguments, and various things to trigger errors. It passes all of those satisfactorily. Now we've put the try catch round. So we can see we've passed all of the tests for the last step of the coursework. So one of the things I haven't been making explicit in the videos is that once we've saved it, done all the changes we need to do, a commit into Visual SVN to make sure all the changes that we want are committed to our source control database. And we should do the same on our server. so we can make sure that we have committed all the changes. Very good. So we can check with the coursework assignment now that we've done step 7, finished testing. Now for step 8, we actually have to create a zip file and a readme for marking, and we can hand it in. So we can look at that and do a final wrap up of how you package the work. It says here what you must deliver in the next video.